Jai Hind, dear students. I am Dr. Preeti Mittal, and today we are going to start with the revision of the chapter Acids, Bases, and Salts. This chapter has a weightage of 7 marks in your board exams. From this chapter, you will be having one MCQ for 1 marks, one fill up the blank, one very short answer type question that is again for 1 marks, and one question will be there for 4 marks. So it has a total weightage of 7 marks. It's very important for your exams. So we are going to start with the chapter, and let's see. First, we are going to talk about acids and bases, and then we'll come to salts. Acids are the substances which have some general characteristic features, like they are sour in taste, usually like you have tasted lemon juice, so that is having citric acid. You must have tasted tamarind, so that is having tartaric acid, even sour curd, that is having lactic acid. So different acids are present in these items which make them sour. Apart from that, if we talk about bases, they usually have a bitter taste, a soapy taste is there. Even the soap that we use at our home, that is having a basic nature. There are certain substances by the use of which we can find out that if a given substance is there that is having acidic nature or basic, that is acid or a base. We can test that by using certain indicators. You must have heard about litmus paper. We commonly use it for acids and bases to find out whether the given substance is acid or base. So such substances which can indicate or which can let us know that a given substance is acidic or basic in nature are known as acid-base indicators or simply indicators. Now let's have a look about different types of indicators. These indicators could be like natural indicators. Natural indicators include litmus paper. Litmus paper, you must have heard about it in your previous classes also. It's basically purple in color and it is derived from a plant lichen. Lichen is a plant that belongs to Thallophyta group, and from that we get the litmus paper, and that litmus paper, when it's neutral, neither acidic nor basic, then it's purple in color. Okay, but you all know that on reaction with acids it turns red, and if you are making to react with base, then the litmus paper turns blue in color. B for base, B for blue in color. Then we have turmeric also, that is also a natural indicator. You must have seen sometimes that when you spill something, some food item on your dress or something on your fabric, and when you wash it with the soap, and the soap being basic in nature, that turmeric area that turns red, that shows that turmeric on reaction with bases turns red. That is again a natural indicator. Apart from that, there is red cabbage leaves. If you take the red cabbage, that will also act as a acid base indicator. Apart from that also, there are petals of certain flowers like petunia, hydrangea, geranium. These petals are also natural indicators. Next, we have synthetic indicators that are found in the laboratory to test whether it's an acid or base. Two examples of that is methyl orange and phenolphthalein. They also show different colors. For example, methyl orange is, when it's neutral, it's orange in color, turns red on reaction with acids, and turns yellow on reaction with a base. So it's methyl orange, phenolphthalein. These are both synthetic indicators. Next comes olfactory indicators. Olfactory indicators are especially useful for a person who is blind. So, if a person is blind and he cannot test whether a substance is acidic or basic by these tests, that students could be made to learn about acids and bases by olfactory indicators. For example, onion, clove, and vanilla. These are all olfactory indicators. If you take any of these and make it to react with acid, there will be no change in their smell. But their smell will fade away if you react them with a base. Okay, these details, that what happens with these indicators on reaction with acid or on reaction with the base, these are not given in NCERT. So for your exam papers, you can just remember the examples of natural indicators, synthetic indicators, and olfactory indicators. That's all for your exams. Now we'll see the reaction of acids and bases with different substances. Okay, so let's see first the reaction of metals with acids and bases. When metals reacts with acid, they produce salt and hydrogen gas is liberated. One such reaction is when we make a reactor HCl, that is hydrochloric acid, with zinc, then zinc chloride is formed and hydrogen gas is liberated out. How can we test it? For this test, we can carry on an experiment. In a test tube, we can take some zinc granules and put some H2SO4 or that is sulfuric acid or HCl. When we react with dilute sulfuric acid or dilute hydrochloric acid, then what is going to happen? That ZnCl2 will be formed, zinc chloride will be formed, or zinc sulfate in case of sulfuric acid, that will be formed. Apart from that, hydrogen gas will be liberated out. Now, we pass this hydrogen gas, whatever gas is coming out, we pass it through a test tube, through a delivery tube, and connect it to a soap solution. When it passes out through a soap solution, then it is going to form some bubbles. And in these soap bubbles, hydrogen gas will be trapped. So we can find out where is this hydrogen gas. Now, when we bring a burning candle next to it, it will blow off with a pop sound. So wherever hydrogen gas is liberated, it could be tested by bringing a burning matchstick or burning candle, and that will blow off with a pop sound. So that is an indicator that hydrogen gas is liberated out. For this, one diagram is also given in the book that was asked some 2 years back in the board exams. So I would advise you all to go through these diagrams as well. So that is reaction of acids with metal. Okay. Then if we see the reaction of bases with metals, all the bases do not react with metal, but some bases are there that are going to react with acids. One such base is sodium hydroxide. So when you react sodium hydroxide with zinc or any other metal, then sodium zincate is formed, Na2ZnO2. This is sodium zincate, Na2ZnO2, and again hydrogen gas will be liberated out. Fine. So you have seen the reaction of acids as well as bases with metals. Both of them are going to liberate out hydrogen gas that burns off with a pop sound. Fine. Next we have the reaction of acids like hydrochloric acid or any other acid also you can take, and make it to react with metal carbonates or metal bicarbonates. Here I am taking the example of Na2CO3 or NaHCO3, metal carbonate or metal bicarbonate. You can take other metal carbonates also. So when they are going to react with HCl or any other acid, they are going to produce salt, like in this case NaCl, plus water plus carbon dioxide gas will be liberated out. Now, how will you come to know that which gas is liberated out? We are talking about chemistry, so we need to prove that which gas is coming out. So, the presence of carbon dioxide could be tested by passing the gas through lime water. What's lime water? CaOH whole twice. Calcium hydroxide. Its common name is lime water. So, we pass carbon dioxide gas through lime water. What will be formed is calcium carbonate and water. Calcium carbonate will be formed. Now, this calcium carbonate is a white precipitate. It is a white precipitate, and so it will turn our lime water milky. Our lime water will be turning milky because of the presence of this white precipitate, calcium carbonate. Remember, this calcium carbonate is having the same formula as that of chalk or marble or limestone. So, calcium carbonate, you must have seen marble or chalk, they are also white in color, and this calcium carbonate is also having the same formula. Okay, then again water will be formed. Now, one more question could be added up with this, that suppose you have a question in your exam that we react metal carbonate or bicarbonate with an acid and a gas is released. On passing this gas through lime water, it turns milky. But when we pass this gas continuously through this lime water in excess, then once again the solution becomes clear and it's colorless. So what is the reaction going on during this process? So in the first step we have seen salt and carbon dioxide gas was formed along with water. This carbon dioxide gas turned the lime water milky because of formation of white precipitate of calcium carbonate. Now when we continue to pass some more carbon dioxide through it, we are continuously passing carbon dioxide in excess, then what will be formed? Calcium bicarbonate or calcium hydrogen carbonate will be formed. Now this calcium hydrogen carbonate, it's soluble in water and it will not be having that milky appearance. So again, once again, our solution will become colorless. A good question to be asked in exams, right? Next comes the reaction of, now why we have discussed only the reaction of acids with metal carbonates and bicarbonates? Why we are not discussing the reaction of bases with metal carbonates and bicarbonates? Because bases do not react with carbonates or bicarbonates of metals, because these metal carbonates and metal bicarbonates itself are basic in nature. Okay, so metal carbonates and bicarbonates are basic in nature. That is why they are going to react with acids only and not with bases. Next is the reaction of metal oxide with acids. One such example is we make react copper oxide, which is having a black color, and that is made to react with hydrochloric acid, HCl. What will be formed? Copper chloride and water will be formed. This copper chloride is bluish greenish in color, and due to the change in the color of the solution, we can easily find out that the reaction has occurred. Okay, so this is bluish greenish in color, and so it will form the color change will be there, and by that we can find out that the metal has reacted, metal oxide is reacted with hydrochloric acid. Okay, so from black color it will be turning blue green in color due to formation of copper chloride. Again, why metal oxides are reacting with acids? The same reason, because the metal oxides are themselves basic in nature. Metal oxides are itself basic in nature. Oxides of metals, earlier also we have discussed that oxides of metals are basic and oxides of non-metals are acidic in nature. Okay, so now if we talk about non-metal oxides, they are acidic in nature, so they are going to react with base. They are going to react with a base. So what will be there? Suppose we consider the example of one of the non-metal oxide like carbon dioxide. When it will react with a base like calcium hydroxide, we have seen the reaction earlier also. So it is going to form calcium carbonate and water. Calcium carbonate and water will be formed. So this is an example of a reaction of non-metal oxide with a base. Fine. Now, what will happen when acids and bases are dissolved in water? If acids or bases are dissolved in water, then they show ionization. In the presence of acids or bases, in the presence of water only, these ions will be formed, and that is why acid is going to show their acidic behavior only in presence of water. Similarly, bases will be showing their basic behavior in presence of water. So in presence of water, what will be the reaction? When acid reacts with water, then hydronium ions are formed. H3O plus is hydronium ion and Cl minus is chloride ions. So hydronium ion and chloride ions are formed, and since these ions are formed, so that that will be showing the acidic behavior. One experiment is also there for that. That if you have you form some HCl gas that is not having any water content in that, and you make it to react with litmus paper, what will be the color change that you observe? So you will find that the litmus paper is not going to turn red even in the presence of that dry HCl gas. If the HCl is not having any water content in it, that will not be showing its acidic properties, and our litmus paper will not be turning red. But now, if you just moisten that litmus paper, if you make it moist and then pass the HCl gas, you will find that our litmus paper is going to turn red. This experiment proves that the acids show their acidic behavior in presence of water only. Okay. Next is bases. Now, all bases are not soluble in water. Some bases only are soluble in water. I told you in metals and non-metals also that some bases are soluble in water, and those bases are sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide. These are four examples. Okay, so first group and second group of the periodic table, their bases are soluble in water. Okay, so how will they form their ions? When they are in water, then NaOH will dissociate into Na plus and OH minus ions. Sodium ions will be formed and hydroxide ions will be formed, and because of the formation of these ions, they will be showing their alkaline behavior, that is, they will be turning the red litmus paper to blue. Okay, apart from that, two more important things are there about these reactions. One is dilution of acid. When you are mixing an acid in water, I told you hydronium ion and chloride ions are formed. So whenever you are diluting an acid, there is a proper process for that, that how you can dilute an acid. You will say that either you can add water into acid, or you will add the acid to water. Anyhow, you can dilute that, but it's not so. Whenever you have to dilute an acid, then you take some water and slowly add some acid into it. You cannot take some acid into in a container and just put water into that, because it's a highly exothermic reaction. Dilution of an acid, remember, it's very important that dilution of an acid is a highly exothermic reaction. It's going to liberate a lot of energy. So whenever you have to dilute an acid, you always slowly add acid to water, and never add water to an acid, because if a lot of acid is there, then a lot of heat will be there. Okay, so you take a lot of water and slowly add acid to that, so by that way your acid will be diluted. It's very important for your exams. Okay, so that is there, that how you need to dilute the acids. Some more questions are there based on this, like example, when we have seen that metals reacts with acids, so based on this only you can be having a question that why is it advised and why it is not advisable to set curd in a vessel made up of copper or brass. We never use copper and brass vessels to set curd. Whenever you have to set curd at home, your mother usually takes something made of stainless steel or something made of glass, but not of copper or brass. Why is it so? Because metals, when they react with acid, that is like lactic acid in case of curd, then they are going to have some reactions in that. Metal salts will be formed, and that will change the taste of our curd. So we never set curd in copper or brass vessels. Okay, all this what we have discussed is very important for you. We are going to discuss now the questions from the textbook, and we are left with two more reactions of acids and bases, that is how acids react with bases, and how and we also have that they both conduct electricity. We are going to discuss that, but first you can take a screenshot of all that, so that you can just have a quick revision using all this. Okay, so I hope you have taken a screenshot. Now um, now we have that the acids as well as bases, they can conduct electricity. Okay, we have seen five properties, two more were there, but there was no space to write that here. So I skipped out those two. That is, one is acids and bases, they both conduct electricity. Okay, so since they are having ions in them, they dissociate into ions, and that is why acids and bases both can conduct electricity. Second thing is about that what happens when acids reacts with bases. Okay, whenever acid react with a base, then salt and water will be formed, and this reaction of an acid with a base is known as, tell me the name of the reaction, think of it. Yes, it's neutralization reaction. Acid reacting with a base, that is known as a neutralization reaction. Okay, and salt and water will be formed. Okay, so for example, if HCl, can I erase this off? I'll be writing here now. If HCl reacts with a base like NaOH, then what will be formed? NaCl, that is a salt, and H2O, that is water, will be formed. And this is an example of neutralization reaction. Such a reaction is known as neutralization reaction. Okay. Before moving on to the questions of the textbook, just quickly have a recap once again. Acid basis indicators could be natural, synthetic, or olfactory. Two examples of each. Let's find. For natural indicators, we have litmus and turmeric. For synthetic indicators, we have phenolphthalein and methyl orange. For olfactory indicators, we have vanilla, onion, and clove. Then we have seen the reaction of acids and bases with different substances. First, starting with metals. So when metals reacts with acid or bases, hydrogen gas is liberated out. That could be found out by the pop sound of the burning candle. Next, we have seen about reaction of acids with metal carbonates or metal bicarbonates. Only acids are going to react with these because these carbonates and bicarbonates are themselves basic in nature. So when they react, carbon dioxide gas will be formed apart from the formation of salt and water. This carbon dioxide could be tested by passing it through lime water, which is going to turn milky. Now, if we continue to pass carbon dioxide through this lime water, then again the solution will become colorless because of the formation of calcium hydrogen carbonate. Next, when we have seen that metal oxides are themselves basic in nature, and so they react with acid and produce salt and water. Okay. Let's have an example. Copper oxide, which is black in color, it's going to react with hydrochloric acid and form blue greenish color copper chloride and water. It's again a neutralization reaction example. Next, we have seen that non-metal oxides are acidic in nature, so they are going to react with base and form salt and water. So when carbon dioxide reacts with calcium hydroxide, that's going to form calcium carbonate and water. Next, we have seen that on reaction on dilution, they are going to show ionization. Their ions will be formed. Now, let's quickly just we'll go through some of the questions given in your book, so that could be an important questions from for your exams. Also go through each and every diagram of this chapter, because sometimes questions are asked based on diagrams also, or you could be asked to draw a diagram for this chapter. You have 4 marks question, so on that you could be asked to draw a diagram. So and some of the questions: why should curd and sour substances not kept in brass and copper vessels? We have already discussed that. Okay, one of the question is which gas is liberated when acid reacts with metals? So you all know that it's a hydrogen gas. Next is a metal compound A reacts with dilute hydrochloric acid to produce effervescence. What is effervescence? Effervescence means quick escape out from some gases. For example, whenever you open a cold drink bottle, then you see that the carbon dioxide gas in that is coming out quickly. So that is an example of effervescence. Quickly, when some gas is escaping out, that gas could be usually carbon dioxide, and that is known as effervescence. It comes out in the form of bubbles. You can clearly see that bubbles coming out. Remember about the cold drink. So the gas evolved extinguishes a burning candle. Obviously, if it is going to extinguish a burning candle, then it is carbon dioxide gas. Write a balanced chemical equation for the reaction if one of the compound formed is calcium chloride. Okay, now we have that calcium chloride is formed, and we know that brisk efflorescence is there that shows carbon dioxide gas is formed. So we know the name of two of the products, and we have to find out what were the reactants. So let's see that. So we have seen that a metal compound A was there, and it is made to react with dilute HCl, dilute hydrochloric acid. And what was formed is calcium chloride and carbon dioxide. A gas was escaping out that extinguishes a burning fire candle. That means it is carbon dioxide, and calcium chloride is also formed in the reaction. It's already given. So what could be this compound? Since calcium is there, so we must be having a compound of calcium only. And since carbon dioxide gas is liberated out, so means it must be having some carbon and some oxygen in it. So it is calcium carbonate. Calcium carbonate, when reacts with hydrochloric acid, it's going to form calcium chloride. Carbon dioxide gas will be liberated out, and what else will be formed is water. Now let's balance this equation. Yeah, it's balanced now. So this could be the answer for question number 3 of this in-text question given at page number 22. Next we have some more questions. Let's just go through them. Why HCl and HNO3 show acidic behavior in aqueous solution, while solutions of compounds like alcohol and glucose do not show acidic behavior. Or you can be asked why alcohol and glucose do not conduct electricity. For both the questions, the answer is the same, that they do not. Alcohol and glucose solution do not form ions when dissolved in water. So their solution is not going to conduct electricity, and their solution is not going to show the acidic nature also. Why aqueous solution of acid conducts electricity? Because it forms ions, and so electricity will be conducted, and so it will show the acidic property also. Okay. Now next is how you will dilute an acid, that we already discussed. Next is how is the concentration of hydronium ion affected when a solution of an acid is diluted. Okay, so if you have a solution, for example, if you have HCl and water, and you all know that hydronium ion will be formed. Now, if you carry out the dilution of that, if you add a lot of water, okay, suppose you have something in your with you and you carry out its dilution, then suppose you have some solution of like a blue in water. Blue means like Nil. You put some Nil in water, and now if you put a lot of water, what will be there? It will be diluted, and so the amount of that Nil in that water, that concentration will be reduced. So similarly, when you continue to dilute an acid, this hydronium ion concentration is also going to fall. So the acidic nature of that solution is also going to reduce, and it's going to become less acidic. उसका acidic behavior कम हो जाएगा. It will be less acidic in nature. Next is how is the concentration of hydroxide ions affected when excess base is dissolved in a solution of sodium hydroxide. So you have a sodium hydroxide solution NaOH, and you know that NaOH solution will form sodium ions and hydroxide ions. OH minus ions are known as hydroxide ions. Now, if you add more NaOH, then more OH ions will be formed, and the basic nature of the salt is also going to increase, and hydroxide ions will also be increased in the solution. So, when you add base to the solution, its hydroxide ion concentration is also going to increase, and its basic nature is also going to increase. Okay, so I hope you are clear with everything. We are left with the pH, discussion of the pH, how pH is important in daily life, and about some common salts that we will see in the next video. That's all for today. Good day, everyone.